Okay, guys, welcome to Thursday's Corporate Finance 2 class. So basically on Tuesday, we talked about how to calculate mean, average, standard deviation, and variance. And if you recall, we have actually two cases. The first case is you have some sort of probability distribution. So given distribution, right? um, you should be able to calculate mean, standard deviation, and variance. And then the second case, which is more uh, realistic, you have some historical data. For example, you have some historical returns. Now, given these returns, how should you be able to calculate the average return, the standard deviation of the return, and the variance of the return, right? So these are the basic skills you have to develop after the first class. I would say that um, these calculations are fairly simple because clearly, if you understand those formulas, you should be able to plug in numbers and do the calculation, right? And now, and at the end of the last class, we sort of started thinking about portfolio, right? So the first step to think about portfolio is to think about how to calculate its return and how to calculate its volatility. And then to get to this step of doing some actual calculation, we have to first understand what is a portfolio weight. Right? So we talked about this last class. Basically, portfolio weight is the value of a certain investment divided by the total value of the portfolio. Right? So it's a very simple calculation, and we also have done a simple example, and we calculated we calculated the portfolio weights of Disney stock and Coca-Cola stock. So today, let's see what we can do with the so-called portfolio weights, right? So the first useful thing about learning portfolio weight is calculating the expected return of a portfolio. So you can see we have this formula here. The formula basically tells you that if you wanted to calculate the expected return of a portfolio, then you just need to calculate the weighted average of the expected returns of the investments within that portfolio. So this is the formula. You can see that you have a long formula here, but what you really need to know is this and this, right? These two steps are basically middle steps. I put these middle steps here because I want to show you how to get this result. Right? This is the major result. So basically, you could think about a simple case. Let's say you have a two-stock portfolio, right? So you have two stocks. Let's say stock one has a portfolio weight of X1 and its expected return is ER1. Stock 2 has a portfolio weight of X2 and its expected return is ER2. And then according to this formula, you can see that expected return of the portfolio of two stocks is X1 times ER1 plus X2 times ER2, right? Very simple. Okay, now let's see this example here. Suppose you invest $10,000 in the Forzani Group stock and $30,000 in TransCanada. You expect a return of 10% for the first firm and 16% for the second firm. What is the expected return for your portfolio? So now let's see, well, obviously we have a very simple case because it's a two-stock portfolio. So if you think about this formula here, right? Obviously, the first step you need is to calculate portfolio weights. Luckily, we have learned about how to calculate portfolio weights, right? So let's say I would call the portfolio weight of Forzani stock as XF. And then you can see that the value of the Forzani stock is $10,000. And the total value of your portfolio is 4,000. So this gives you a 25% portfolio weight. And then for the second firm, which is TransCanada, let's call TransCanada's weight as XT. So XT is 1 minus 75%. Oops, sorry. 1 minus 25%. So 1 minus 25%, which is, let's see, which is 75%, right? And now let's see. Oh, by the way, you can also use this good old formula, right? You can use the value of Forzani group divided by, you could use the value of the TransCanada stock divided by the total value of the stocks. So this also gives you 75%. And now the question is, what is the expected return for your portfolio? So let's call the expected return of the portfolio as RP. Of course, the letter P represents portfolio. So it equals the weight times the expected return of the Forzani stock plus the weight of TransCanada times expected return of TransCanada stock. So this gives us 25% times 10% plus 75% times 16%. So this gives us a result of 14.5%. Pretty simple, right? Okay, now let's, again, you have this alternative example here. Basically, you have almost exactly the same question. The only difference is you're having different numbers. So you could apply the same methodology using the same approach to get correct answers. Okay, now let's think about the volatility of a two-stock portfolio. So basically, you can see that we have understood how to calculate the expected return of a portfolio. It is not hard, right? I would say it's pretty easy. But calculating the volatility of a portfolio is actually, I would say, somewhat complicated. So here we will actually only want to focus on a simple case. So we will only talk about a two-stock portfolio. The textbook also has a small section on portfolios with more than two stocks. And if you're interested, you could take some time to read that section. So since the purpose is to calculate the volatility of a portfolio, we have to first learn some basic concepts. And based on these basic concepts, then we can calculate the volatility. So the basic concepts we need here are first, covariance, second, correlation. Right? So basically, again, the purpose of learning covariance and correlation is to calculate the volatility of a two-stock portfolio. Okay, let's see how do you define covariance, and then we will talk about how do you define correlation, because correlation is basically based on covariance. So to talk about the covariance, we have two cases. The first case is you have a probability distribution, right? In the second case, you have some historical data. Let's call this historical return because it's a finance course. We focus on return here. So in the first case, when you're having a probability distribution, if you want to calculate the covariance between two returns, Ri and Rj, then the covariance is given by the first formula. And you can see that you could actually decompose this somewhat complicated formula, right? You can see that This part is deviation of return I from its expected return. And the second case is deviation of return J from its expected return. And then you use the first deviation, and you can time these two deviations, and then you calculate their expectation, right? So this gives you the calculation of covariance. And now if you look at this second formula, it's about calculating the covariance from historical returns. And then you can see that the spirit is essentially the same, right? The first one, this, again, it's about deviation from return I to its average return. And the second one is the deviation of return J to its average return. And then you sum up these values and divide it by number of years minus 1. Again, you have to be careful with this minus 1 here, right? So if you have 15 years of data, then you should use 15 minus 1. So why these definitions? Why covariance and why covariance is useful? Well, because by calculating covariance, right? If you get a positive value, let's say if the covariance of Rj and Ri is larger than 0, right? Let's say this guy, right? If this guy is larger than 0, then you would know that the return I and the return J, they tend to move together, right? So they tend to move in the same direction. And then if you have a value of, let's say, if the covariance is smaller than 0, then you would know that return I and return J, they tend to move in the opposite direction. Now, if you get a value which is close to 0, right? Let's say it is close to 0. Then you could say that return I and return J are almost unrelated. Right? How do you get this result, right? Why, if you have a positive value here, then you would know that I and J, they tend to move together. Well, if you look at this formula, right? Look at this formula. If the left-hand side is larger than 0, then it means that most of the time, if Ri is larger than the expectation of Ri, then Rj should also be larger than the expectation of Rj. This implies that if covariance of Ri and Rj is larger than 0, then you could see that whenever Rj is over its average, then Ri is also over its average. This tells you that they tend to move together, right? So that's the explanation, the intuition here. Of course, I know most likely you guys have learned about the definition of covariance. So this should not be hard to you guys. The only difference is here we are focusing on returns, right? Okay, now let's see how could we define correlation. So after defining covariance, we could define correlation. And you can see that correlation is essentially defined by covariance of Ri and Rj divided by standard deviation of Ri times standard deviation of Rj, right? Correlation also tells you how Ri and Rj they are related to each other, right? So basically, if you get a positive correlation, then you would say that Ri and Rj, they tend to move in the same direction. And if you get a negative correlation, then you would know that they tend to move in the opposite direction. The nice thing about correlation compared with covariance is you can get any value from covariance. However, the value by calculating correlation is bounded, right? It is between -1 and +1, right? So let's see what's the meaning of correlation, right? So basically it says that if correlation is close to +1, remember that 1 is the upper bound and -1 is the lower bound. So if you have a correlation which is close to 1, then you would see that return Ri and return Rj are very much related, right? So they very much tend to move together. And then if you get a correlation which is close to 0, now this basically tells you this basically tells you the returns are uncorrelated, which means they're unrelated. So they have no tendency to move either together or in opposite directions. Now the third case, if you have a correlation which is close to -1, you can see that in this case they are actually related. However, they're related in an opposite way, right? So they tend to move in opposite directions. So this nice picture is a summarization of what we have just talked about, right? So you have these extreme cases, right? So they move together, and then these extreme cases, that is, the always move oppositely. Then you have this unrelated case, and then you have these medium cases, right? So if you get a value between 0 and 1, let's say if you get 0.5, right? Then you would know that they tend to move together, but they're not moving together in a perfect way, right? Okay, let's get more intuition from this this correlation values, right? So we could observe what we can get, or what we can understand from using these different pictures. So let's say we have two stocks, right? You can see that you have stock I on the horizontal axis, and you have stock J on the vertical axis. And then we could plot their returns. And you can see that you're having a straight line here. And the slope of this line is obviously negative, right? Because it's downward sloping. So in this case, the correlation is -1. And then you can see that stock I and stock J's returns, they move in opposite direction, right? Which means if stock I's return is higher, then stock J's return has to be lower, right? Okay, now let's see the second case, that is graph B here. Now you can see that, okay, this is graph B. Now you can see that stock I and stock J's returns are somewhat related. However, you can see that there are a lot of noises, right? You can see that you can sort of draw a trend line. This is a trend line, right? However, that it's not perfect because a lot of points, they're not lying on this line, right? So this is not perfect, which means in this case you have negative correlation, but it's not perfect. And now if you look at graph C here, if you look at this graph, you could see that, well, actually you cannot observe any kind of relationships between these two stocks, right? It's as if they move in a random way with each other. So basically in this case, the correlation is just 0. Now, by the same kind of argument, we could talk about graph D. You can see that, again, they're positively related, but the correlation is not perfect. So in this case, we say they have a correlation of 0.5. Now, the last graph, now you get a positive relationship, and they're positively related. They're positively related because you can see that if stock I's return is higher, then stock J's return is also higher. In this case, you have a straight line. And in this case, the correlation is 1. Perfect positive correlation. Okay, now let's do this calculation here. So it says using the data in table. Oops, where's the table? So using the data from this table, table 11.1, what are the covariance and the correlation between North Jet and South Jet, between South Jet and Alberta oil? So our task here is we have this table 11.1, and we wanted to calculate the covariance and correlation between North Jet and South Jet. So this is North Jet, this is South Jet. And our second task is to calculate the correlation between South Jet, right? South Jet and Alberta oil. So now let's see how could we calculate this. First, you can see that you have the, oops, okay, this is weird. Okay, first you can see that you have the answers in table 11.2. That is your answer is pretty here. So this is the answer. So let's see how could we do the calculation here. First, you can see that we want to calculate covariance. What is the formula of calculating covariance? Remember that we have learned about this. That is covariance of, let's say we want to first calculate the covariance between North Jet and South Jet, right? So here, the covariance between the North Jet, I will use Rn to represent the return for the North Jet firm, and Rs, which is the return for South Jet. Note that we're having some historic returns here. Right? We're not having a probability distribution, right? Because you have years here and you have the realized returns for these two firms. So it's 1 divided by t minus 1 sigma, which is the sign about the summation, right? And what do we want to sum here? Well, we want to sum Rn minus Rn bar, which is the average return of North Jet, and times Rs minus Rs bar, which is the average return of the South Jet. So you can see that it's, I mean, mathematically, it's not hard, but you can see that you have multiple steps. So you can see that this table gives you this clear demonstration, what kind of steps you need to take to get your result. So let's see how the table does the calculation here. What you can see from this formula is, first, you have to calculate these deviations, right? And then you can see that the table here, this row and this row, gives you deviations, right? And after getting these deviations, you wanted to multiply this deviation with this deviation, right? So where do you get these multiplications? Oh, it's here, right? And after getting these multiplications, you want to sum up these values, right? Okay, how do you get this summed up value? This one, right? And after summing up these values, you want to divide this sum by number of years minus 1. You can see that this is what you can get here. And after getting covariance, we could calculate correlation. You can see that correlation equals covariance divided by standard deviation of stock I and the stock J. So how do we get standard deviation? Oh, we have standard deviation of this and the standard deviation of this. So basically, the correlation of North Jet and South Jet equals covariance of North Jet and South Jet divided by standard deviation of north jet times standard deviation of south jet. And we have found out correlation is this guy here. That is point, right? It's 0.112. And then standard deviation are here, right? These are two standard deviations. So it's 0.134 times 0.134, which gives you 0.624, right? And remember that you have this second question. It says you also need to calculate the covariance and correlation between South Jet and Alberta oil. Well, the methodology is the same. The formulas we use are the same. So I will skip this step. I will just briefly talk about how do you calculate South Jet and Alberta oil's correlation. So you can see that we have the same steps here, right? This multiplication. And then we will sum up these values, get this negative value. And then we will get covariance. So after this, we get a negative correlation here. Now, after finishing our calculation, let's actually look at these numbers and see what kind of interesting result we can get here. So let me first remove these marks. Right? So they're actually distracting. Okay, now let's see what kind of result you can get here. So first you can see this. First, you can see that you have different kinds of correlations, right? This correlation is positive and it's kind of large. This correlation is negative, right? So basically this tells you that the return of north jet and the return of south jet, they tend to move together. And the return of south jet and Alberta oil, they tend to move in the opposite direction. Why this is the case? Well, it's very easy to understand, right? Because north jet and south jet, they're both I think they're some sort of airlines, right? So they're both airlines. So their performance are quite related. Their businesses are very much related. So that's why you get this positive correlation here. Now think about SouthJet and Alberta Oil. What you can see here is SouthJet is a airline, and Alberta Oil is an oil firm. So let's think about the price of oil. If the price of oil is low, then SouthJet will have good performance because oil is a cost to SouthJet. And then if the price of oil is low, then Alberta oil will suffer. So its performance will be bad. So you can see that from the perspective of oil prices, you can see that the return of SouthJet and the return of Alberta oil should be negatively correlated. Okay, I think that's the interesting economics we could get here. Oh, there's a second point to make here. Although it's a little bit early to make this point, but we could just read these numbers and get some or try to understand why do we get these numbers. So if you look at these portfolios, right? So this portfolio is 50% in NorthJet and 50% in SouthJet. And the second portfolio is, so this is the second portfolio, is about 50% in SouthJet and 50% in Alberta oil. So what I can see here is they have the same expected return, which is obvious because all these stocks, they have the same expected return. So if you put these stocks into your portfolio, of course, your portfolio should have the same 10% return. However, what you can see here is you have different volatilities, right? So if you combine Southjet and Alberta oil, you will be better off compared with the first portfolio, right? So the second portfolio is better because you have a lower volatility. It is less risky, right? So why do you get this result? Well, as I said, we have not formally talked about this. However, you can imagine that there is some sort of nice benefit from diversification because here, the return of Southjet and the return of Alberta oil, they tend to move in opposite direction. So you can see that the ups and downs, they will tend to cancel out with each other in the second portfolio. So generally, it means the return for the second portfolio compared with the first portfolio will be much smoother. So if you have a smoother return, this basically means your portfolio is less risky. Right? Okay, now let's look at the next question. It says, what are the covariance and the correlation of a stock's return with itself? So now, of course, we are dealing a special case here, right? We're thinking about a stock's return with itself. So let's see what is covariance RI and RI, right? Because we're trying to calculate the covariance of a stock's return with itself. So we have learned about this. It's the expectation of RI minus ERI times what? RI minus ERI. Right? So you can see that these two terms are the same, which means you have ERI minus expectation squared. And this is exactly the definition of variance, right? So basically the correlation of a stock's return with itself is this stock's variance. Now, correlation. So correlation of RI and RI equals covariance of RI and RI divided by standard deviation of RI times standard deviation of RI. And we have learned covariance of RI is variance of RI. And we also know that standard deviation is the square root of variance. So basically, standard deviation squared equals variance. So this is 1, right? So the correlation of a stock return with itself is 1. This is easy to understand, right? We have learned if you have a correlation of 1, then you could say that these two returns are perfectly correlated. And this is obvious. A stock's return, obviously, it is perfectly correlated with itself. So you will get a correlation value of 1 here. Okay. So here we have a table which gives us volatilities and the correlations for selected different stocks. We will basically use this table to do some calculation here. What else you can see from this table? Well, you can see that first, this number. Well, it says Microsoft has a perfect correlation with itself. Well, we just learned about this, which is obvious. Now, if you compare these two correlations, you can see that Microsoft has a correlation of 0.62 with Dell, but it has a much lower correlation, which is 0.1 with General Mills. Again, you should be able to explain this, right? You can see that both Microsoft and Dell, they are in the IT industry, right? So you can see that because they belong to the same industry, then the return of their stocks tend to be correlated. And now Microsoft is in IT industry, then General Mills, I don't know what's let's just say General Mills is in food industry, right? So you can see that a firm in IT industry should naturally have low correlation with the firm in the food industry, right? So that's why you get a 0.1 here. Okay, now let's see this example. Computing the covariance from the correlation. Okay, so you can see that this one is about computing covariance from the correlation. Remember, what is the definition of correlation, right? So let's say we want to calculate the correlation between Rj and Ri. And we have learned this equals covariance of I and j divided by standard deviation of I and j, right? Now, what does this tell you? Well, this tells you that if you have covariance and standard deviation, you should be able to calculate correlation. But this also tells you if you have correlation and standard deviation, you should be able to calculate covariance, right? This is very important because a lot of problems in this course will actually rely on this result, right? So covariance of I and j equals correlation of Ri and Rj times standard deviation of Ri and standard deviation of Rj, right? Again, I will emphasize this formula is important. A lot of problems, if you want to solve them, you have to use this formula. Okay, so now let's see how could we use this formula to find out the covariance between Microsoft and Dell, right? So covariance of Microsoft and Dell equals to their correlation. What is their correlation? Well, we have 0.62 here, right? Their correlation is 0.62. Now, we also need standard deviation, right? So standard deviation of Microsoft, what is, okay, so standard deviation of Microsoft is 37%, and Dell is, and for Dell, its standard deviation is 50%. So times 0.37 times 0.5. So this gives us 0.1147, right? So it's a pretty simple calculation. The only caveat is you have to know that you should be able to convert or given correlations, you should be able to go from correlation to covariance. Okay. After talking about covariance and correlation, we could finally talk about the variance of a portfolio. Again, as I said, we would just focus on a two-stock portfolio. So this formula gives you the this formula tells you how to calculate the variance of a two-stock portfolio. So basically, let's say we have stock 1 and stock 2, right? And let's say stock 1 has a portfolio weight of X1 and stock 2 has a portfolio weight of X2. So in this case, the variance of this portfolio equals X1 squared, which is the squared value of the first stock's portfolio weight times the variance of the first stock's return. And this one, in a similar way, it's the second stock's portfolio weight squared times the variance of the second stock's return. And plus 2 times, again, portfolio weight of the first stock, portfolio weight of the second stock, and covariance between R1 and R2. A lot of times, the problem will not directly tell you the covariance between two stocks. Instead, it will basically just tell you the correlation. Again, covariance should be calculated as correlation of R1 and R2 times standard deviation 1 and standard deviation 2, right? You have this proof here, which shows you why could you get this formula. But you can see that this one is optional, right? It is not required. So if you're interested in the mathematical details, then you can read this proof yourself. Okay, now let's see how could we calculate this problem. It says using the following data from table 11.3. What is the volatility of a portfolio with equal amounts invested in Microsoft and Dell? What is the volatility of a portfolio with equal amounts invested in Dell and Alaska Air stock? So, well, let's solve this, right? So we have two. So for the first portfolio, you would invest 50% in Microsoft and in Dell. So here the portfolio weight of Microsoft is 0.5 and Dell's portfolio weight is also 0.5. And now let's see what is, so we also have Microsoft, we also have the standard deviation of Microsoft stock, which is 37%. And we also have the standard deviation of Dell, which is 50%. And we further have the correlation, right? We have the correlation between Microsoft and Dell. So I will just use the notation CORRMD to denote the correlation between Microsoft and Dell. So we have 0.62 here, right? Now we have a portfolio of Microsoft and Dell. So the volatility, right? Okay, let me see what's the question here. So what is the volatility, right? Let's first start calculate the variance. So the variance of this portfolio is, remember to calculate variance, you should use this formula, right? This formula here. So the variance of this portfolio is Microsoft stocks portfolio squared times its variance, right? So times its variance, right? And plus Dell stock squared times its variance, right? Well, because the standard deviation of Dell is 0.5, then the variance of Dell stock should be 0.5 squared, and plus 2 times portfolio weight, right? Times covariance. However, we don't have covariance here, right? We don't have covariance between Microsoft and Dell. So we will use correlation to back out their covariance. And covariance of Microsoft and Dell is equal to correlation times the standard deviation of Microsoft times the standard deviation of Dell, right? So this will give you the correct answer. I think it's 0.1541. Now, what is the volatility? Volatility is the square root of variance. So it's the square root of 0.1541, which gives you what? Okay, so this gives you 39.3%. So this gives you 39.3%. And you also have the second question. It says, what is the volatility of the portfolio with equal amounts invested in Dell and this Alaska Air, right? Basically, you can see that the steps would exactly be the same. The only difference is you will have to plug in different numbers because now you're having a different firm, which is the Alaska Air stock. Right? So I will just skip the second question, and of course, when you're at your home watching this video, you should solve the second question by yourself as a practice. Okay, so here we have the volatility of a large portfolio. This section is just optional, right? So it is not required, but you can see that how this works, right? If you have more than 2 stocks, how could you calculate the volatility of this large portfolio, right? So basically, you can see that if your portfolio contains more than 2, then what you're gonna calculate is you will calculate each pair's covariance times their portfolio weight, and then you will sum up all these values. Again, you have this proof here, which is obviously not required. Okay, now let's see a special case, right? As I said, this formula is not required. However, now we will talk about a large portfolio with many stocks. However, this is a very special case because it is equally weighted. So this section is actually required, and it's actually quite important. So first, what is the equally weighted portfolio? Well, this is easy, right? It basically means that you put the same amount of money in each investment, in each stock in your portfolio, right? When you're having this special case, right, equally weighted portfolio, then the volatility of the portfolio becomes quite easy to calculate. So here you have this formula here, right? It tells you that the volatility of this equally weighted portfolio's return equals 1 divided by number of stocks. Here, this letter N represents number of stocks, right? So it's 1 divided by number of stocks times the average variance of individual stocks plus 1 minus 1 divided by number of stocks times average covariance between different stocks. Okay, now let's see several special cases. So here you can see that we have 3 important special cases. The first case is if N becomes very large, that is, you have hundreds of thousands of different stocks in your portfolio. And then the second special case is if stock returns, they all have the same distribution. However, they are independent. The third case is stocks returns have the same distribution. However, they are perfectly correlated. So let's go through these special cases one by one. Okay. Okay, now let's talk about the first case. Oops. So the first case is N is very large, right? So we have a lot of stocks. Now, if you look at this formula, you can see that if N is very large, then this implies 1 divided by number of stocks approaches 0, right? I have this right arrow, right? This one, right arrow. It means approaches, right? Or close to. So it's close, so 1 divided by N close to 0. In this case, it means variance of this portfolio equals, you can see that this becomes 0. This becomes 0. So it equals to average covariance, right? Average covariance. So that's why you get this first result. As number of stocks grows very large, the variance of the portfolio equals average covariance between different stocks. Right? Now, let's talk about this second special case. Right? So the second special case says all stocks have the same distribution, and they're independent, right? And independent. Now, if all stocks are independent, this implies covariance between two stocks is always zero, right? This is just from the definition of independence, right? So if X and Y, they are independently distributed, then covariance between X and Y has to be zero. Now, we also have the other assumption, that is, all returns have the same distribution. So if all returns have the same distribution, then all returns will have the same variance, right? That is, all stocks, they will have the same variance because they have the same distribution. So if they have the same variance, then average variance will be equal to a individual stock's variance. So the first assumption tells you average variance equals to a single stock's variance. Right? So if we combine these two results, we can see that in this case, variance of the portfolio equals 1 divided by n times average variance, right? You're getting this result because in this case, the second term is zero because average covariance between the stocks equals zero. And now because average variance equals a individual stock's variance, so it becomes a single stock's variance divided by number of investments in your portfolio. Now let's look at this the third case. The third case, it says stocks have the same distribution, but they're perfectly correlated. So if they have the same distribution again, we will have the same result. That is, average variance equals a single stock's variance. But now we don't have independence here. So we will have to change this second assumption into perfect correlation. And if these stock returns, they have the same distribution and they're perfectly correlated, then covariance equals variance. Now, let's see what we can get here. So according to this formula, you can see that if we have covariance equals variance, then basically what we can get here is n times a single stock's variance plus 1 minus 1 divided by number of stocks times a stock's variance. Well, the reason, you can get this is because covariance equals variance. And we know that variance or average variance equals a single stock's variance. So you can see that this and this, they will just cancel out. So now you will have variance of RP equals a stock's variance. Okay, let me repeat these results and see what kind of understanding we can get from these three special cases. Now, for the first case, it tells you that if your portfolio is fairly large, then how the stocks within this portfolio are related is very important, because the variance of your portfolio's return depends only on the average covariance. So if these stocks within your portfolio are fairly or very strongly related, then the average covariance will be large. So the portfolio's return will be large. So the portfolio's volatility will be large. Now let's look at the second case. The second case says returns have the same distribution and they're independent. And then you can see that the variance of the portfolio equals the variance of a single stock divided by number of stocks. This is nice. It means as you increase n, right? As you increase n, the variance of your portfolio's return decreases. In plain English, this means as you add more and more stocks in your portfolio, your stock becomes less risky, right? So this is nice, right? Again, you can see that this is only under a special condition, that is, stock returns are the same and they're independent. However, in the future, you will see that generally, even if stock returns are not exactly independent, you will generally get some benefit by adding more stocks into your portfolio. You will get smaller variance. Your portfolio will become less risky. Basically, this is the idea of diversification. Right? Now, the third case is similar to the second, except these stock returns are perfectly correlated. Right? In this case, you can see that the variance of your portfolio's return equals the variance of a single stock. Now, what you can see here is the 1 divided by number of stocks has disappeared, right? You don't have this term here. This is bad for you because it means that the variance of your portfolio's return does not depend on how many stocks do you have in your portfolio. This means even if you add more and more stocks into your portfolio, the risk of your portfolio will not decrease. Well, why do you get this result? Well, because in the second case, stocks are independent. So it basically, again, it basically means as you add more and more stocks into your portfolio, ups and downs, good days and bad days will cancel out with each other. So the return of your portfolio will be smooth. So you will get a small risk. And now, this case, perfect correlation. It means that if one stock is doing great, all stocks are doing great. If one stock is having a bad day, then this implies all stocks are having a bad day, right? This implies that there is no such canceling out each other effect. So basically, your portfolio have to experience a lot of peaks and troughs, bad days, good days. So the return of your portfolio is not smooth at all. So the variance of your portfolio is actually quite large. And one thing is you can see that the second case and the third case represents extreme cases, right? Because generally you can see that stocks in the, generally generally, you can imagine that stocks are not perfectly correlated. However, they're not independent either. So you can see that in reality, you will just fall between these two extreme cases. That is, as you add more stocks into your portfolio, the variance of your portfolio will decrease. However, the effect is not. However, there is some limit to this to this diversification effect. Okay, now let's see. What would happen in reality. So generally, okay. So basically, this picture tells you a more realistic picture. So here you can see that as you add more and more stocks into your portfolio in the beginning, right? You will have this very nice benefit. Again, this is due to diversification. I know I have not formally talked about diversification. So in this section, you can see that there is a large reduction in portfolio volatility as you increase the number of stocks. However, you can see that on this right side of this picture, you can see that in the end, if you have already added, like, let's say 800 stocks into your portfolio, then adding more stocks will not generate a huge reduction in your portfolio's risk, right? So it basically means that there is some upper bound or there is some limit in this risk reduction as you increase more and more stocks into your portfolio. Okay, now let's see this example here. Stocks within a single industry tend to have a higher correlation than stocks in different industries. Likewise, stocks in different countries have lower correlation on average than stocks within Canada. What is the volatility of a very large portfolio of stocks within an industry in which the stocks have a volatility of 40% and correlation of 60%? What is the volatility of a very large portfolio of international stocks with a volatility of 40% and a correlation of 10%? Okay, you can see that we don't have a lot of numbers here. So this is actually a pretty simple question. However, I have to tell you that during last or previous semesters, a lot of students actually made mistakes in questions like this. So you should be careful and you should make sure you understand how to do the calculation here. Okay, now let's see how do we solve this. So it basically tells you have a very large portfolio, right? You have a very large portfolio. Now, this is a special case of what? This is the first special case, right? So you have a very large portfolio. It means the variance of your portfolio equals average covariance. Right? So let me write down here. So the variance of your portfolio's return equals average covariance. What is average covariance? Note that you have volatility and you have correlation, right? So obviously you have to back out covariance from correlation, right? So here covariance equals correlation times standard deviation of the first. Okay, okay, so covariance of stock 1 and stock 2 equals correlation of stock 1 and stock 2 times standard deviation of stock 1 times standard deviation of stock 2. So here you can see that we're trying to calculate the average covariance here. And now you can see that these stocks have a volatility of 40% and a correlation of 60%. So you would plug in this 60% here. And how do you get this volatility? You have only one number, right? Well, you can see that it says stocks have a volatility of 40%. So basically, we are assuming that all stocks have the same volatility. So times 0.4 times 0.4, right? I think this gives us, I don't know what's the number here. I think, okay, it's 2.4 times 0.4. I think it's 0.096. So this is just a covariance between stock 1 and stock 2. However, you can imagine that for this problem, if you calculate stock 1 and stock 3's covariance, it's still the same number, right? So this implies the average covariance is just 0.096. So if we have the variance, now we could find out what is the standard deviation, right? So the standard deviation is square root of this number, which gives you 30 something, so 31%. Okay, let's calculate the second question. So what is the volatility of a very large portfolio of international stocks with a volatility of 40% and a correlation of 10%? So I will just directly do the calculation here. Square root of variance, and variance equals average correlation, and variance equals average covariance, and covariance equals correlation times volatility. So this is 0.016, I think. Am I right? Yeah, I think I'm right. Okay, so this gives you 12.6%. Now, if you can compare these two cases, right? What I can see here is for the first portfolio, you have 31%. For the second portfolio, you have a much smaller volatility. Why do you get this? Well, if you compare numbers, you can see that the only difference is their correlation, right? So for the first portfolio, you're having stocks within an industry. In this case, correlation is large. And then for the second case, you have a correlation of 10%. It's fairly small. Of course, the economic explanation for the 10% correlation is because you're having this international stocks. So supposedly we should have smaller correlation compared with firms within the same industry. So what I can see here is the correlation between stocks matter, right? In the first case, if stocks have a high correlation, then the resulting portfolio will have a high volatility. In the second case, if correlation is small, then the resulting portfolio will have a large volatility. So this is fairly intuitive, right? Again, it's the same argument about diversification, right? Because they have small correlation, then diversification benefit will be large. Okay, now let's see the last question before ending today's class. What is the volatility of an equally weighted average of n independent identical risks? So let's remove the word risks. Let's call this returns, well, because our focus is really about returns, right? So let's say you have this independent identical returns. What is the volatility here? Let's see what kind of special case we're talking about here. Well, you're right. We're talking about the second case, right? We're talking about this case here, right? The stocks returns, they have the same distribution and they are independent. And we have learned the variance of the portfolio equals the variance of the individual stock divided by number of stocks. So what's the question asks about? Well, it asks the volatility, right? So first we start from variance. Variance of RP equals a single stock variance divided by number of stocks. Now, let's call the, okay, I use letter sigma to denote a single stock's variance. So it's just, oops, sorry, it's not a nice way to represent single stock variance. So let's call the single stock variance as sigma squared. So the variance of the portfolio is equal to sigma squared divided by n here, right? Okay. Let me remove these fancy letters. Okay, let's call this as standard deviation squared because we know standard deviation squared means variance divided by n, right? So the standard deviation of the portfolio return by definition is the square root of variance of this portfolio return, which is the square root of standard deviation squared of a single, sorry, here standard deviation refers to the standard deviation of a single stock, right? So divided by n, which is SD of a single stock divided by square root n here. Now you can see that this is exactly the same answer as this, right? Well, what does this tell you? Again, it says if you have these uncorrelated independent returns, as you increase the number of n, right? If n increases, you can see that the standard deviation of the portfolio will decrease, right? So you could benefit from this very nice diversification benefit, right? As you increase the number of stocks into your portfolio. Okay. Let me see if I have time for this. Okay, so okay, a application of this result, that is this result, is about estimation error, right? So what is this estimation error? Of course, it's the error on your estimation. Whenever you're trying to use average return, right, to estimate the true return, there will be some mistakes. There will be some estimation errors. Now, how do we measure this estimation error? Well, we could use standard error to measure this estimation error. So now let's see how could we calculate standard error. Again, we assume stocks returns are the same, and we assume they are independent. So again, we are talking about this case, right? And we're also talking about this case, right? And we have done the exercise, and we know that if stocks they are independent and they have the same distribution, we could have this formula, right? Now, if we use this formula to think about standard error, well, by definition, standard error is defined as the standard deviation of average returns, right? And we learned about this, right? So standard deviation of average return, Okay, let me write down this. Standard deviation of average return. Right? What is the average return? You can actually consider average return as the portfolio return of an equally weighted portfolio, right? So in this case, we have learned, okay, let me write down this. So average return can be considered as a portfolio return with equally weighted stocks, right? And we have learned about this, right? Standard deviation of this portfolio's return is just standard deviation of a single stock's return divided by number of stocks, right? So that's why you could get this formula on this page. And then you can see that this actually is quite nice. It basically tells you that if you're estimating returns, right, the error of your estimation will be smaller if you have a higher number of observations, right? Okay, that's for today's class.